All right, Unit 3, Lesson 3, Measuring Dilations. So in 3.1's exercise here, we got dilating out. And what they want us to do here is they want us to dilate the triangle FGH using center C with a scale factor of 3. So that means the distance between our points, our vertices, F, G, and H, are going to go out 3 times as much from the center C. So, for example, F or C to F, that segment right there, if I can get it to line up there, there we go, is going to extend itself 3 times as much. So there's 2, and here's 3. Okay, so hopefully I lined that up perfectly. So F is now going to be further out. All right, I'll mark it and denote it as F prime since it's after the dilation. G is going to do the same thing. Okay, so from C to G, it's going to have the same effect. Looks like, there we go. Okay, let me see, copy. Oops. There we go. So there's a scale factor of 2, but they want 3, so 3 times the distance. So G prime is now further out away from C, 3 times as much. Okay, I'm going to do the same thing with H. So C to H is that distance. Okay, so there's H prime. And I'll go ahead and connect the vertices. So what do you notice? What do you wonder? Okay, what do you notice about the relationship between the original sides to the new sides? Hopefully you realize that, for example, FG to F prime G prime, they're parallel, right? So every corresponding side here is parallel to one another. Now, this is a transformation, but is not rigid. Okay, so these two triangles are far different side lengths. Okay, so think back about side, 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 right? So it doesn't preserve congruency here. All right, so moving on. All the scale factors. Here's a center of dilation and a triangle. Okay. And then they say measure the sides of the triangle to the nearest millimeter. Unfortunately, we're not in class, so that's going to be a little difficult. It does say that I will assign a scale factor. Okay, well, let's just do that then. Let's just focus on applying a scale factor. Okay, and that's using our point of projection, point C, in relation to F, G, and E. Okay, E, F, G. Let's see. So how about we try a scale factor of 2? Okay, and then I want you to try a scale factor of a half. Okay, what do you think is going to happen for number 1, for scale factor of 2? Is your triangle going to get larger or smaller? Is if you, in number 2, if you use a scale factor of a half, is your triangle going to get larger or smaller? Okay, so that's something to think about. All right, so you can choose to draw this. It's up to you. on paper, or you can use Cami. It's really up to you on your comfort level. So let's go ahead and do number 1. Here's my distance from C to F. Here's my, let's do one vertex at a time. Here we go. Okay. So F is way out here now. Let's go ahead and get to G. So G prime is way further out. It looks like my points of, my lines of projection here are a little off. Right, so this may not be what I've been wanting here. It's doing like this auto alignment deal with my lines here, so that's throwing some things off. Okay, there's E prime. Okay, let's go ahead and connect those dots, see what our new dilation looks like. Our points aren't, come on, there you go, come on. Okay. So as you can see, I'm just connecting the new vertices as best as my pen can get to my custom marks. There you go. So as you can see, the triangle is definitely 2 times bigger. Okay, it dilated. Okay, so that's the result for number 1. Okay, let's try the result for number 2. I'm going to go ahead and erase at least my scale factor of 2 markings. And let's do number 2. Okay, so half, right? So the distance here is halved. Okay, I'm assuming I'm cutting these perfectly in half. I could always do constructions. So if you have a compass at home, just do perpendicular bisectors for those points, those reference points, and you should get your exact midpoints. Midpoints because we're cutting these segments in half, right? The distance is halved. So there you go. Let me clean up my lines here. There we go. So remember, the main idea here is if the scale factor is greater than 1, like with number 1, your image, your figure gets larger. But if your scale factor is a fraction that's less than 1, okay, between greater than 0 and less than 1, right, a fraction, that's less than 1, you're getting smaller, okay, in reference to wherever your center of dilation is, which again, in this situation is point C. Okay, moving on. What stays the same? So if we were to do a dilation of ABCD using center P and your scale factor, complete the table. Let's see. So PA prime, so P to A prime. So wherever your scale factor is, let's say, well, 2 is a little too large. Can we try half? Let's do half. Okay, I choose to do half. Because if I get larger here, it's going to get all over the place. It's going to turn into a real mess. So as you can see, I'm just taking into consideration my point of projection, or my center of dilation, which is point P. There we go. There we go. And halving that. That looks about half. That looks about half. I think I went a little too far on that one. No, right here. There we go. The reason I know it's right there is because A and B are perfectly horizontal across to one another. So A prime, B prime is going to do the same thing. Okay, so orientation is similar. Different spots, but very similar. All right, and let's see. P to C, same thing. Orientation, there we go. And let's go ahead and connect my new vertices. There's my new parallelogram or quadrilateral. Okay. And let me go ahead and clean this up so you guys can see the new figure. There you go. Okay, so D prime is here, C prime is here. Okay. What do we notice? What's the same? So PA divided by PA. The value should be half, right? So everything's being half because the scale factor that I applied was half. So I applied my scale factor to be 1/2. So it doesn't matter what side is going on, it's still just going to be half. So PA, right, or PA prime, or I'm sorry, the distance from P to A prime is going to be half of the distance from P to A. Okay, that's where I'm getting the half from. All right. That looked like somebody's face for a second. That was pretty cool. So again, PA is, or P to A prime is half of PA. Okay. And that's the same with every single segment in relation to P. So just be aware of that. Your scale factor is a constant across all the parts, all the sides in relation to your center of dilation. Now they're talking about the relationship between the sides. So this is the distance from your point P of projection, right? Your point of projection, projection, right? And these are your sides. And guess what? Your sides have the same relationship to one another as does your distance from the point of projection. They all underwent the scale factor of a half. So B prime A prime is half of BA, right? Same thing with C prime, B prime divided by CB. Same deal. Okay. So in synthesis for the lesson, if you want to make a scaled copy with the sides twice the length of the size original, where you place E prime, it's definitely got to be in relation to your point of projection, right, which is O here. And if you were to do it twice the size, well, it's going to be twice as far, right? So they say E right now is 8 units away from O. Well, that means you're going to be 8 more units out here off the screen, right? With the scale factor being twice as much, right? So they're kind of hearkening back to scale factors. All right. Now, if it's let's see, if they said what if it's half, right? Then what's half of 8? It's 4, right? So that would be applying a scale factor being half. Okay. So remember with dilations, your distance can get smaller, right? or your distance can get much larger depending on what your scale factor is. Okay, so remember every point you're projecting, all right, is going to have to go in reference to where your point of projection is, whether it be point O or P or C, whatever they labeled it back in the examples or any problem that you see in the future. Okay, that's it. Have a beautiful day.